The next question here, which one is not considered a myocardial perfusion agent? Well, again, pyrophosphate. Okay, so you need to become familiar of what it is that we're looking for. On this one over here, which category of heart imaging agents is based on Saperstein's principle of compounds having high extraction by an organ of interest? Okay, and actually the only answer on this one is the perfusion.
What's Saperstein's principle?
Yeah, that's Saperstein's principle. This is the whole basis of myocardial perfusion. The amount of radiopharmaceutical going to an area of the heart is dependent upon blood flow. That's the best way to define it. You won't find, I mean, you'd have to look up Saperstein's, but it's one of the things that used to be a big, you know, when they're talking about myocardial testing, okay? Then the other thing down here, okay, which radiopharmaceutical is an analog of potassium?
Thallium.
Yeah, thallium. Remember, thallium and potassium both have a positive 1 valence. Yeah, and quality control on thallium, they're looking for a thallium that has a +3 valence, which isn't incorporated into the myocardium. Okay, all that.
Radiochemical?
That'd be radiochemical, yeah, purity.
Okay, can you repeat from the beginning the letters, the answers?
Okay, the first one here would
So you're gonna
be
email us,
letter
right?
C. I'm going to send you an email with the answers on it, but I wanted to kind of give you an idea of what to expect. And some of the other things here. The other test that I sent you, that was actually one that I gave at Charles Drew, and it does have the answers with it. But those are very similar in nature to what you would expect to see on your boards. This one here is just sort of like, okay, sort of a preview type thing. Yeah, so let's see, which radionuclidic impurity is not assayed in,
Is that E?
actually it's letter A.
It's not assayed for?
Yeah. Radionuclidic is everything other than, remember this is a radiochemical impurity here.
Is that like
Radionuclidic would be everything else though.
TLC, thin layer chromatography?
Yeah. On number 8, because we're looking for a difference in the valence, that would be a radiochemical impurity. Radionuclide impurity, you know, you will find lead, you will find other isotopes of thallium in there with different energies. So when they manufacture 201 thallium, they have to make sure that it doesn't have any of these other contaminants in it. Okay? Because when you're bombarding the target, remember, you don't get a pure target. There's no way that you can remove every single atom of the different isotopes in the target. So the problem is that you're always going to get these impurities. Now this one here, okay, like I said, this is a radiochemical impurity, so that's the only one that would be an issue. Okay. The pH, remember, what is the pH of most of our radiopharmaceuticals?
6 and 7.
Yeah, somewhere in a normal pH range. Okay. The stuff about the decay and everything like that, I'm not going to worry too much. You guys don't need to worry about that. But on these next questions, okay, again, when I put together the new test for you, which will probably be next Wednesday, I'm going to try to use actual images. I'm going to see if, you know, it's a real nightmare to, you know, usually, like I said, for me it's easier just to draw it, but sometimes you really don't know what you're looking at when I draw it. So on these things down here, okay, you should be able to recognize all of these, right? On this question here, do we ever do a thing with letter A? No. Okay, you know, mainly you start out with a short axis view, right? But normally when you first do the composite, when you do the first reconstruction, you have the, which view is this?
Vertical.
Vertical or horizontal?
Vertical.
A horizontal long axis?
No, that's vertical.
You think so?
Yeah.
It
It's
depends.
horizontal is a C.
Okay? This is the one that you normally identify to the computer where the apex of the heart is, right? Or do you guys do that? Have you guys processed images? You have to draw a line that tells the computer where the apex is? Okay, and why is that important?
Because that's how the rest of the images are reconstructed,
Yes.
in a sense.
Well, yeah, what it's going to do is when you're doing, one of the quality control tests that we talked about for SPECT imaging was, let me just get to that for a second. I gave you some examples of quality control of SPECT imaging. This is the back part of that handout that I gave you. But like I said, normally after you've done the reconstruction, then you have to do the alignment. Okay? And so you notice on the test questions, I'm going to be asking you the anatomy for the reconstructed images. Okay?
Like what?
So like on this one here, what would number 1 be?
Apex.
Okay, apex, what would number 2 be?
No, septal.
Septum, be the septum. What's number 3?
Lateral.
Okay, that'd be your lateral wall. Okay. And then on number 1, like I said, for this one over here, you need to be again able to identify what the different anatomical parts are. I was just wondering, on my
So when it's in that orientation, we're supposed to know that that's the short axis?
yes, yeah, they're on your board exams. They're going to give you the picture, and they're not going to tell you what it is.
We say
I mean,
donut.
that's going to be the
Called the donut view.
Yeah.
I don't know if you can.
Vertical.
Can you guys see the answers here? Like that's
It's
interior.
Vertical
Yeah.
and it's like that.
Huh?
You can visible in the notes.
Okay.
Is it visible in the notes? Okay.
Alright.
Well, because I,
Oh, okay. But like, what I'm asking is vertical and horizontal, it's going to be in the right orientation, right? Like, because they both kind of look the same.
which one looks
So
the same?
vertical and horizontal axis.
Vertical is always gonna be backward C's, right?
Yeah. Well,
No, I
yeah.
know,
The
but you
vertical is
can-
always going to be the backward C,
There we go.
and then the horizontal is going to look like an upside down U or an N.
Well,
I
Or a upside down V.
an upside down V. Yeah. Or somebody who had Parkinson's.
Looks like a slug climbing a wall.
I was thinking
Short
like,
axis, like a
let's
slug
just
climbing
switch
a wall.
around. Like how the vertical very much like look like horizontal,
So it's always
and then
gonna
the
be in the right
horizontal is more like
orientation, right?
vertical.
Because
So you
can
just
really
switch
adjust-
around and that's it.
Well, yeah, normally, like I said, with the short axis, you're always going to see usually a complete, or you should see a normal,
And
like the letter
Who goes
O,
into that? Tell me I'm good.
unless you have a defect.
Oh my
Okay.
god, that's so
The vertical long axis, okay, it looks like, say,
Anyone
but the thing is, you need to be able to understand what anatomy it is that you're looking at, okay? Because, again, that's a very, very common question on board exam questions. So you've got the septum, the apex, lateral wall. So, I mean, obviously that's very important to me, or I wouldn't emphasize it so much. And if we go back to our questions here, okay, so you can expect to see questions on the anatomy of the different parts of the heart. And then also you notice that I've got the blood vessels here. So the right coronary artery,
Where?
okay,
Are you out?
left main here, which one's this?
Where are you pointing to?
We're on number 5, the
You
identification
can't
of the
really see
anatomy.
it.
Can you scoot it up, please?
Oh. Let me see. Why is it not? Hold on a
It's
second.
frozen.
Yeah.
Oh, no wonder I was like, where are you pointing?
There we go.
There it is.
Okay, So I would expect you to be able to know the normal anatomy of the heart. And on the quiz that I would give you, I would say, okay, which artery is the like the circumflex artery on this? Okay, so number 3 would be the answer, that type of a thing. It's basically going to be off of that diagram that I have.
So one is the right and two is the left. Right?
Yeah, and normally they're not going to put the diagonal or the marginal arteries. I mean, I might have it on there, but
And 3 is the circumflex.
the 3 is circumflex. But then on question number 6, okay, you should be, yeah, the number 1 up here, SA node. And the question you might also expect, besides being able to identify that that's the SA node, is which part of the EKG would this be responsible for?
Oh,
Is it P?
Yeah, this would be your P wave, and then the PR interval is the amount of time that it takes for it to travel from the SA node to the AV node. Okay? Yeah. And then we have, the bundle of His, and then from the bundle of His you've got the right and left bundle branches. Okay, the right and left bundle branches are the ones that make sure that the ventricle has a coordinated contraction. Okay, that's why if you have a blockage there, you get that little spike. That's what you're looking for, because if one of these is contracting and then the other one is delayed contracting, that means that you don't have a uniform expulsion of the blood. You should also be aware of where the blood goes when these different things contract. Well, the atria, we know, pushes the blood into the ventricle, but then you need to know, during the QRS complex, where does blood go in the right ventricle? Okay, the QRS is the contraction of the ventricles. So yeah, so in the right ventricle it's going where? Okay, the pulmonary arteries. And what valve does it go through?
Tricuspid.
Okay, it goes through the pulmonic tricuspid valve, not the semilunar valves, yeah.
So
Yeah,
the tricuspid is the one going from the atrium to
The ventricle.
Yeah, here's the tricuspid valve here. And sometimes they'll ask you a question that says, okay, blood going from the right atria to the right ventricle goes through what valve?
Tricuspid.
Okay, the tricuspid. Okay, and then we have the semilunar valves, which are the pulmonary artery and the aorta. Okay, so again, you need to keep that in mind. And remember,
one from right ventricle to pulmonary.
oh right, okay, that's the pulmonic valve. And it's a cusp. Semilunar. Yeah, there's like 3
Is that
semi.
semilunar / pulmonic? Is
Yeah.
it the same?
Yeah,
So which one is it to the aorta?
it's aortic. It's also
Aortic
semilunar.
/ semilunar, okay.
Yeah.
Right semilunar, got it.
Okay. So you need to kind of refresh your cardiac anatomy. So remember, you have the mitral or bicuspid valve over here, and as I said, what we're looking at with the EKG is, that the QRS is the actual, electrical impulse coming out of the bundle of His, and do that. Okay. What other things do I have on here? Okay, on this one here, when I put this test together, I wanted to include every possible type of question that you might see. So again, so we have, I want you to be able to identify what the different positions and projections are. Here's some stuff about the EKG, okay, and that's also in the handout that I gave you. In there somewhere. And I will, like I said, I'll send you the answers. I just need to find them. Okay, it's.
I think he gave us the answers for like
I gave the answers for the other test.
half, or just 50 down or something like that. Is that right?
I'm not. If whatever I sent you is on here, but again, some of the things that you should know is, even if your heart gets wiped out, it's still able to beat. you know, so that they have different things for beating, like it says the AV node, how many pulses per minute, which is about 40 to 60 beats per minute.
Is that
Um,
more? It's
No,
higher.
not for the AV node. The SA has a higher rate,
Yeah, that's right.
but the AV node isn't as fast. But like I said, the specific questions about, I would probably say the test that I developed in 2008, 2009, the one that I sent you from Charles Drew, that's a little bit more sophisticated. And I actually have a test that I'm going to send you that I made up from Ann Steve's chapter. I was going to send it to you, but for some reason when it copies, it's too light. You can't see it, so I'm going to have to kind of freshen it up a little bit.
Last week you said you're gonna send us the slideshow. Remember?
Yeah, you got it.
Mhm.
I sent them.
You did?
Yeah. There's two PowerPoints that I sent you. One is nuclear cardiology, and the other one is cardiac.
Monica, can you send it to me, please?
Did you get it?
I didn't. So I almost emailed you last night and asked if I didn't. Seriously, I didn't have it.
'Cause I resent them out this morning, right? Or last night, I don't remember.
It's there.
I resent it out.
It's
'Cause
right.
Ashley was telling me that she didn't get it, so. And also, how many of you guys got that one for the University of Arkansas, the 100 question test? Review test. It's all different
review
types.
test to study.
Did you send it to us?
Yeah. Ashley, where did you find that the University of Arkansas thing?
Is that what it's called?
A student told me about it.
Yeah.
Where's that?
Maybe I haven't sent that one out to you because
No.
that one covers like everything. It's a broad spectrum type of test. Every year, the Society of Nuclear Medicine at their annual conference has a nuclear medicine review, and the University of Arkansas has been, sort of handling the stuff. But the students have told me that most of the class is kind of a waste. But the thing that is important is that they do give you a very good book to study, and also questions. They don't change the questions that often. That's why over the years I've got like maybe 10 years of their books. So the ones that have different questions, I've sent those or given those to the students. So those I will be sending out. I don't know if it's a little bit early to be giving it to you now because you've kind of got enough stuff, but I guess it's something we can do. Okay, on this other stuff here, okay, some of the other questions. When we're talking about phase analysis, which study do we do in nuclear cardiology where we analyze the phase analysis of the heart?
Question is that?
What question number is that?
Question number, this one here, the contraction and the relaxation of the atria are out of phase with each other by how many degrees?
Oh.
Would that be a letter?
What's that?
I would guess D.
It's the MUGA study.
Oh.
Oh, but it's 180 degrees. Okay, and if you guys have done MUGA studies, part of the answer to your MUGA study okay, this is your phase analysis here. So you're not only looking at the, you're looking at the ejection fraction. You can measure the time interval and calculate the speed or the volume and the speed that's being ejected out of there. There's another thing that you can look at here. This tells you when it's detecting what the ejection fraction is. There's a thing that we call the derivative of the slope. Okay. What they're talking about with this derivative of the slope is how much of a change is there between adjoining pixels. And let me just see if I can find it here. This is what they're looking at here. Okay, we have these different regions here, and when you have the automatic edge detection, okay, what the computer is doing is it sends out these ray paths. Remember what a ray is? Okay, we have a line that has an endpoint, and then it sends out something from there. Okay, so in a MUGA study or any of your other automatic region of interest, whether it's for kidneys or anything, the computer is going to look for the area that has the highest number of pixels, or the highest number of counts in the pixels. So it's going to assume that's the middle of your left ventricle. Do y'all agree?
Yeah.
Okay. So once it detects that, then it's going to send these ray paths. It typically sends out 64 in 64 different directions. So if we have like 1,000 counts here, okay, as it moves out, so where it says letter A, 75%. So if you have an ejection fraction of 75%, that means you have 1,000 here. So this thing over here, what's 75% of 1,000? Okay, 750. Okay, so if it detects pixels of 750 counts, it's going to assume that that's the edge of the end systole. So you have end diastole and end systole. Okay? And then as you move further out, with less contraction or less wall motion, you have less number of counts in those pixels. So what it's saying here is that as it goes along, it's measuring the number of counts that are in each pixel, and typically it calculates what they call the second derivative. But here, what it's basically looking at, so like if there's 450 counts in this pixel and 1,000 here, that's 45%, so that's a 45% ejection fraction. Does that make sense? Okay. So basically, if you're doing the automatic thing, but as far as phase analysis goes, basically what the computer is looking for are parts of the heart that aren't beating in unison. So in other words, both atria should contract and both ventricles should contract at the same time. If it detects an area where that isn't happening, it will make it like a different color. So if I see a black area here, that tells me that that part of the heart is not beating, or it's not, it's out of phase with the rest of the heart. And that usually is indicative of what they call a pseudoaneurysm. So in other words, you have an area of the heart where the tissue has died, and when the heart contracts, the scar tissue kind of balloons out. Okay, and they call that a pseudoaneurysm. Okay, but that's one of the things that you're looking for with that. Okay. Then some of the other questions that I was kind of looking at here. Okay, remember we have positive and we have negative infarct imaging agents.